Now, the Graham's law seems so very easy if we are given the amount of moles, no, or of a particular gas that has entered or that has transferred from one container to another in the time that it took for them to travel. However, now what if a case goes like this? So, for instance, now there's a story. Now, two prisoners are imprisoned in a microscopic world, no, in a microland, if you may call it, or micronation. And suddenly, no, they were able to open the bars that are imprisoning them. The two inmates, no, namely xenon and argon, both gases, tried to escape. Before they escape, they have to run a long road, no. Before they claim their way to freedom, they have to travel some distance, no, before getting out of the prisoner or the juvenile. Now, the deputy or the chief, no, if you may call it, the periodic table chief, chased down these two prisoner. Who do you think will be chased down first? Is it xenon or is it argon? I'll give you 2 minutes to think. You may now pause the video and think. Alright, if you find it difficult to answer since there's not much given here, no, that is fine. No? It's okay. However, if you tried thinking different things, just like if you recall, no, our mind exercise a while ago, why is that Ma'am Irma and Sir Levin can enter or cross the hole in 10 seconds while Marian, ka-tsimek Marian and ka-tsimek Jello can cross it in 15 seconds? It's because Ma'am Marian and Sir Levs is lighter as compared to Ma'am Marian and Sir Jello. So meaning, the lighter the object, the human or the gas is, the faster they can move around in a constant temperature. And if you thought of that way, or if you check the weight of these two elements in the periodic table, you got it right. So, in order to determine which one will be traveling faster between the two, we need to check their molar masses, no? So, what is a molar mass? Yan. A molar mass is just the atomic mass unit, no, or the mass of a particular atom in grams per mole. So you can check this in your periodic table of elements or in the internet. Xenon weights, the weight of the xenon is 131.293 AMU. So this is your atomic mass. Don't get confused. This is the weight, no, the average weight of the atom xenon, while argon is relatively lighter, 39.948. So technically, argon can run faster if it's a human or can move faster as compared to xenon. So, to convert the atomic mass unit to molar mass, papalitan lang natin to ng grams per mole, no, to get the molar mass. So, take note of that because we'll be using molar mass in a bit. So, remove atomic mass unit. We use grams per mole. Yan. So, again, argon can move faster and xenon will be chased down first. Now, this is what Graham's law of effusion is really all about. Now, Graham, after several experiments, realizes that gases moves at different rate, and he thought of several reasons, no, as to why some gases moves faster, some are not, 'di ba? Even in perfumes, did you even ask yourself, bakit mas mabilis kong naamoy yung pabangong ganto, paka-spray ko, tapos yung ito naman na isa, matagal bago ko siya maamoy, 'di ba? That's why there are perfumes that are expensive and are good in brand, and some are not that expensive and not that good. No? It's because of the different rates of effusion of particular gases, specifically at constant temperature. So to formally define Graham's law of effusion, no, the rate of effusion of a gas is inversely proportional to the square root of the mass of its particles. Now, saan to galing? No, Graham used the kinetic molecular theory and created his own equation. So if you can remember, kinetic molecular theory, temperature at constant temperature, the kinetic energy or the average kinetic energy of any gas is just equal. So at constant temperature, if you can remember the formula for kinetic energy, that's 1/2 mv squared. Kinetic energy is equals to 1/2 mv squared. And we learned that the kinetic energy is just your temperature. No? Huwag kakalimutan yan. Temperature is not the hotness or coldness. Temperature is the average kinetic energy of a substance, specifically a gas, here in our discussion. So at constant temperature, xenon and argon will probably have the same kinetic energy. So if we were going to illustrate that, since the same ang kinetic energy nila, we can compare them as this one. So, yan. Bear with me, my pen, digital pen. So, 1/2, since this is equal to kinetic energy, we say that xenon is 1. So, m1, the mass of xenon and the velocity of xenon. Mass of argon and the velocity of argon. And by the way, don't get confused. When we talk about small m, we are talking about mass. When we talk about capital M, we are talking about molar mass. Small v represents velocity. Capital V represents volume. Alright? So don't get confused. So eto na. We cancel 1/2 since we can multiply it by 2. The same. And we transfer both mass on the left side and velocity or on the other side, or the other way around. No? By associative property, it's the same. So, by doing so, we can get, we can divide both sides para makasabay kayo. V2 by V2. Yan. So, we cancel V2. Cancel V2. We have here m1 v1 squared over v2 squared. No, I forgot to write the squared. Alright. Now, we need to remove m1. So, I'll copy it here. 1 squared. So that I can isolate the velocity on this side and the mass on the other. So, what I need to do is to divide it by the mass, or m1. Or I can divide them both, no? Pero inisa-isa natin para makasabay lahat. So, m2 natira dito over m1. Alright, m1. This is small letter m. Alright. And then this will cancel out. And we will be left with yan. We will be left with, let me write it here, v1 squared, v2 squared, v1 squared over v2 squared, v2 squared, m1, m2 rather, m2, yan, over m1. So again, apologies for my handwriting. Medyo, mahirap talaga magsulat dito sa net. Alright. To get rid of the square, I need to place them in a square root. And we'll get v1, or the velocity of one gas over the velocity of the other, is equals to, yan, square root of m, small letter m2 over small letter m1. But since we are talking about gases, no, we don't use the letter V, but rather we use the letter R, no, the rate. No, we don't use velocity. So gaganyanin mo lang siya, R. 'Di ba? Ang talino ni Sir Jello, R, R1, R2. And since the masses that we are going to talk about are molar masses, so we make it molar mass. So, it becomes capital M. So, habaan lang natin, capital M. Ang talino talaga ni Sir Jello. And notice that they are inversely proportional. So, the molar mass of R1 is in the denominator, while the molar mass of R2 is in the numerator. And if I have to write it individually, if I'm looking for the rate of effusion of a specific gas, so say for instance, the rate of the xenon, so RXE, I'll be using the formula 1 over the square root of the molar mass of yan, X. Nadidelay ang ating discussion. Yan, MXE. Alright, so this is now the formula for the rate, the Graham's, ano yun? Ba't naging ganito? Whoa! This is now the formula, mayroon palang ganito, for the Graham's law of effusion. So, paano kaya ito ibalik? Escape? Okay na. Yan, nawala. So, this will be, let me write it once again, my bad. The formula now for the rate of effusion will be 1 over square root of the molar mass of that particular element. And if we are comparing yan, para mas cleaner, yan, or more clean. And if we are comparing two gases, we can use this formula. So Graham came up with these two particular formula. And this is now, ladies and gentlemen, the Graham's law of effusion. Now, for items number 2 and items number 3, calculate the rate of effusion of xenon and calculate for number 2, xenon, for number 3, calculate for the rate of effusion of the argon. So, binigay ko kanina yung molar masses nila. So, it's very easy to solve. So again, the rate of effusion according to Graham is 1 over the square root of the molar mass of the specific element. Now what if I want to compare, the distance, the discrepancy in the distance between the xenon and argon, the prisoner that were being chased. So gaano kalayo yung agwat nila. So by the molar mass itself, you'll get an idea that we already answered that the xenon will be chased down first. The xenon would be left behind. Balikan lang natin yung slide with the xenon. So the xenon would be left behind because it's heavy and it moves slower as compared to the argon. But what if I want to solve the rate, or the ratio between them? That's the ratio is simply the rate of the diffusion or effusion of both of the two gases. So I'll be using 131.293 and 39.948. 131.293, 39.948. Yan, pag inuutosan ka, ganun baga, 139.293, 31.248. Natandaan ko, sana natandaan ko. 131, dito na lang ulit. 39.948, 39.948, and then 131.29. Yan na lang gamitin ko. 131.29. 39.948. Yan, bawang sibuyas. So, I'll be using this equation. Yan, bawang sibuyas. Bawang ang pinapabili, bawang. Tapos pagdating sa tindahan, sibuyas ang sasabihin mo. Hindi ko rin na-memorize, so useless. So, yan. The given are the molar mass of XE. which is 131.29. So for those who are wondering saan to galing, again, it's in the periodic table. It's the atomic mass. No, but we convert it to molar mass by simply changing the atomic mass unit into grams per mole. So 131.29, argon is 39,948. 39,948. 39,948. So isulat ko muna to. 39.9.948. This is the molar mass of the argon. By simply using the formula, the rate of effusion, I want to compare the rate of effusion. Kung ano yung nasa numerator, siya yung kino-compare. So I want to compare the rate of effusion of xenon to the rate of effusion of argon. So meaning, since I already know that the xenon will move faster, I should get a value that is less than 1. No, kasi it's a percentage of the speed, no? Or the xenon is much slower than the argon. So that would be the square root of 39.948. You know what? Let me just input this in the calculator. So i-dictate ko lang. Input here the 39.948 grams per mole. Sa baba, or sa denominator, 131.29 grams per mole. So it would be easier for me and for both of us. Alright. So that would be, makalimutin na talaga si Sir Jello. 39, oy, ito ka. 39.948 divided by 131.29. No? Your answer shows up on this side, grams per mole. So the grams per mole will cancel since they are both molar masses. Significant figure is 5. So we'll copy until the fifth significant figure, 30427. 2 comes after, so we'll retain. That would be 0.3427. 0.3427. That's the rate of the effusion of xenon as compared to the argon. Now, since this is a bit not easy to understand, this particular rate by xenon, what if we want to know how fast argon as compared to xenon is? So, gaano kabilis si argon kapag kinumpare siya kay xenon? So, what we are going to do is just to reverse this particular element. So, argon will now be R1, then xenon will be R2. And the molar mass of argon will now be the denominator, and the molar mass of xenon will be now the numerator. So, can you do that? In item number 4, write your answer in just a number. No, kasi si rate of effusion, this one has no unit of measurement since rate of effusion lang naman siya. So wala yung unit of measurement since it's just a rate. So yan. On item number 4, reverse this one. No, argon will be on the numerator, xenon will be on the denominator. So you have to reverse also 131 and 39, and you'll get a whole number, no? Or if not a whole number, a number with a decimal place that will tell you how fast the argon is as compared to xenon. Alright? And then answer it in item number 4 in the Google form. Alright? So, yan, we've solved the mystery kung sino ang mauuna at sino ang dadakip. And then, yan, in your formative, in your task, you are to determine how fast the argon can be as compared to the xenon when running out of prison. Now, to give a common example, probably you are curious. Anong mas madaling maamoy, di ba? Magva-Valentine's Day na. kailangan hindi ako ututin or kailangan hindi ako bad breath. No? These are things na nakakamiss sa actual class. When you enter the classroom, one of your classmates, mabaho yung ininga or may putok or biglang uutot in the middle of the class. No? These are things na that are actually happening, no? And are actually real. No? So we use this as an example. But yan, though it's gross, no, maybe out of curiosity, let's determine what is it that you can smell first. No? A bad breath or a fart. Now, fun fact, I'll still be using the periodic table of elements, by the way, to get the necessary data. So, fun fact, fart is composed of many different gases, but the most smelly one is methane and ammonia. So, for this example, I'll be using methane. And for the bad breath, no, according to a doctor that I've searched in Wikipedia and Google, it's made of hydrogen sulfide. No, that's the smelly stuff. Yan din yung ini-excrete ng egg, no, rotten eggs. Kaya medyo mabaho. So, tingnan natin kung ano yung mas madaling maamoy. So, in order to determine this one, no, we need to simply get the molar masses of each compound. So, methane is CH4. If you remember our discussion on compounds, that's 4. And then, hydrogen sulfide, no, and writing the chemical formula, it's H2S because S is 2 negative, H is plus 1. No? If nakalimutan na to, you can go back to our discussion. It's in the YouTube. No, CH4, what's the molar mass? What's the molar mass of these two? No, and which one is faster to effuse or diffuse, if you might call it, since they are both related. So, in order to do this, no, we have to dissect CH4. So, CH will give us the molar mass. Yan, naglalag. Where's the cursor? The molar mass of carbon is 12.01. No, it doesn't really matter since I'm just going to compare them. Hydrogen, I have 4 hydrogen, and each hydrogen has a molar mass of 1 grams per mole. Hydrogen sulfide, yan, lagay natin tuloy yung particulars para, yan, has 2 hydrogen and 1 grams per mole. So, I'm not writing the unit, pero you should. So, lagay natin para hindi malito. Medyo mahirap kasi magsulat dito. It makes the video longer, no, pag computation part na. Alright. So, yan. This goes until the bottom part. So, sulfur is, I don't know the molar mass of sulfur. Let's check in the periodic table. The molar mass of sulfur is 32.066. So, 32.066. No, wala. And balik. 32.066. Yes. So, medyo mahirap talaga guys magsulat. So, i-dictate na lang natin. Pay attention. So, this becomes 12.01 plus 4. No? The molar mass of CH4 would be 16.01 or 16. While the hydrogen sulfide would be 32 plus 34.066. No? Which one is heavier? Now, this one will be heavier. Thus, this will move slower. So, the methane in our fart will move faster since it's lighter. It's a lighter compound, a lighter gas compound in particular. So, mas maaamoy mo yung utot kung sabay sila. Diba, halimbawa, si classmate mo nag-experiment. Si classmate mo man na isa nag-utot. Yan. Sabay sila. Mas maamoy mo muna yung utot. Diba? That's the reason why, kapag may umutot, it takes a very few seconds, maamoy na natin. Diba? The silent bomb, if we might call it. And for your last task, no, in item number 5, I want you to compare the rate of effusion of methane to the hydrogen sulfide using the Graham's law of effusion formula. So that would look like, so para hindi na kayo mahirapan, RCH4 yan, over, so i-dictate ko na lang din, medyo nahihirapan ng internet. Salamat Converge, shout out sa iyo, no, maghapong ang hina mo. Yan, H2S. So RH4 tapos R of H2S. So the molar mass would be here, molar mass of hydrogen sulfide, square root, tapos square root of molar mass of CH4. Compare the rate of effusion. Alright, so there you have it, ladies and gentlemen. Very simple lang naman ang Graham's Law of Effusion. Because of Thomas Graham, we were able to somehow compute the rate or the speed of how gases diffuse. Diba? It helps us determine kailan ma-inflate ang gulong ng aking sasakyan, kailan mauubusan, kaya hindi siya forever, 'di ba? Ang lobo, no, ang heart balloon, kailan siya magkukupos, 'di ba? Kasi imagine, 'di ba, you stored a balloon from a birthday party, tight naman siya pero for several months lumiliit siya or yan, nai-inflate or nafa-flat rather, no, nagkukupos in Bicol term because there is a tiny hole where gases can escape, no, very slowly. That's what we call the effusion. And maybe you've been wondering bakit naamoy mo yung gantong ulam, yung iba hindi. It's because probably the gases that are being released by that particular food are lighter gas or lighter compounds as compared to those food that you cannot easily smell. That's why we place ingredients that would release this smelly stuff, that would attract our customer. So chemistry is everywhere, no? When you are in science probably you're wondering bakit naamoy mo dun yung balatas, di ba? Things like that. So the Graham's Law of Effusion is very helpful in not actually computing the speed or the velocity of gas, but rather understanding how they behave, and we can use this in different chemistry stuff. So this has been Sir Jello. Thank you so much. Hopefully you learned something in this episode, and we are all done with all of the gases. Thank you so much, and next meeting we'll dive into the quantum world. So see you around, mga ka-tsimek. This is Sir Jello. Peace out.